So, chair cried out. So let's start with 25 and kind of work our way through and talk about, so I want to talk about a couple of things in terms of the word problems. So first of all, nobody should be totally stressed. I mean, yes, there will be a problem like this. But as I told the group yesterday, there will also be other word problems on there that are much more direct. So don't stress about a single problem that's on the test, and think more, I might have, Sam, I'll look in a minute. It's more about getting the whole picture, right? So you might not get a 100% if you're still struggling with this part. And that's okay. This is like a push to see who can really push beyond these standard kind of word problems. And so 25 is, so 25 is kind of one setup of a standard word problem. I'd say 27, I think, is kind of the other setup. And these are kind of the two most typical setup for these system word problems. So in 25, I call these like full sentence problems. So one full sentence is going to give me an equation, and then another full sentence is going to give me the other equation. So we're selling flowers. James sold 9 bags of windflower bulbs and 4 flags of crocus bulbs for a total of 104. Jennifer sold 12 bags of the windflowers and 8 bags of the crocus bulbs for 184. So it's going to give me, sentence 1 is giving me an equation where I have 9x and 4y equal to 104. This is James. He sold 9 of these, 4 of these, made this much money. And Jennifer sold 12 bags of the first and 8 bags of the second and made 184. This is Jennifer. Okay, so I have these two equations. I'm just pulling directly from the sentences. Okay, and that's the setup. And then from there, if it's a problem like this where it's direct sentence, typically we have coefficients throughout. So I'd use linear combination. And what could you multiply on this one to get, and we're not going to solve it all the way through, but to get started, what could you do to start? Yeah, multiply the top. So, okay, well, if I multiply this by -2, then I'd have -18x minus 8y equals -208, and then my y's would cancel, and I could go from there. Okay, and you can always go back and check it afterwards. So remember on your test, if you have time, go back and check things to make sure it makes sense with the original equations you wrote. Okay, so that's kind of 25, like typical setup with full sentence equations. 27 is the other, so I'm skipping 26 right now, is the other kind of really typical situation we see. So on 27, we have this production of Wicked, and it tells us that orchestra tickets are 148. Balcony tickets are 65, and this club spent 2,614 on tickets, and they bought 30 tickets overall. So with this type of systems word problem, we have kind of these 3 pieces that go together. In this case, cost. And so one of my equations is going to be about this cost of the tickets and the total cost that they had. So one equation comes from putting the 3 kind of main components here together. 148 for orchestra ticket, 65 for balcony ticket, paying 2,614. Then I'm left with this other piece, which is like a total, meaning that between orchestra and balcony, I had 30 tickets. Okay, this is a really typical word problem where, again, I have these 3 things that go together, and then a separate piece of information, which is usually like the total amount. And I think, where's the other one that's like this? There's another one like this, I thought. Maybe it's not on here, it might be on the word problem thing. Well, the 28 is kind of like it as well, and we'll talk about 28 as well. 28, we have cost, and cost is going to go together, and then total weight. And really, the alcohol one's a little bit like this too. Okay. So that would be the setup. You could do, I would probably do substitution here, because you could solve for X or Y and then plug in, and just being really careful with the numbers. Okay. Then 30 I'm skipping 26 and 28 right now. What type of one is this? Is this like sentence, or is this like I have a total equation and a cost equation? Which setup is this? Is this similar to 25 or is it similar to 27? Yeah, it's just like 25. It's just giving me different words, really, but the setup is going to be the same. So it gives me Ming sold 11 pecan cheesecakes and 5 apple for 129. So there's an equation. 11x plus 5y is 129. And Willie sold 6x, 8y, total of 160. Okay, there's the other equation. And then, like I said, when I have all these coefficients, I end up having to multiply. And I think on this one, I may have, yeah, I kind of divided because this can all be divided by 2. So I divided this by 2 first just to have smaller numbers, and then went from there. So what I did, if you look at the key, is I said, well, all of this can be divided by 2. So basically multiplied by 1/2 and got a different version of that equation just so I had smaller numbers because they were all even numbers. I cut them all in half. And then I chose to multiply this one by -5, and I multiplied this one by 4 so that I would get 20 and -20. And that's how I solved. Okay. And we'll talk it, again, I'm going to focus on the solving piece when we're solving those questions you asked up above. But you can set it up, it's just solving from there. So now let's look at 26. So these mixture problems, and sometimes, and I showed in the notes, it's helpful to maybe make a table of what you have. And really you don't necessarily need the middle column in this table. So in this particular problem, the mixture or the percentage that we're looking at is what percent of the liters that we have are pure alcohol. So our third column is going to be what percent liters that are pure alcohol in this case. It's not really percent of liters, but like how many liters out of the 100, for example, would be alcohol then if it's a 50% alcohol solution. So we start with kind of the final mixture that we want. So if I want 100 liters, 50% alcohol, I'm going to put that on the bottom. So I want 100 liters and I want 50% of it to be alcohol. If 50% of 100, how many liters of that 100 liters would be pure alcohol? 50, right? Or really I'm saying, okay, take my percent, write it as a decimal, 0.5 times 100, or it's going to give me 50 liters, then would be pure alcohol, and the other 50 would be whatever the other solution is that's in there. Okay, but it's going to be 50% alcohol, 50 liters will be pure alcohol. Then, so we don't have that mixture. We have a 30% and an 80%. So we're going to pour a little bit of the 30%, a little bit of the 80%, and then that mixture in the end will be 50% alcohol out of the 100 liters that are there, okay? So what we don't know is how many liters is 30% and how many liters are 80%. Okay, those are our unknowns. We don't know how many liters, but we do know that one of the mixtures we're adding in is 30%. We don't know how many liters of this, but we know it's 80% alcohol. This is a typo, it should say she. So then the percent, or the liters that are pure alcohol here, the percent we want to change to our decimal, right? So 30% would be 0.3, just moving my decimal place over 2. However many total liters we have, the liters that are pure alcohol would be 30%, of that. However many liters we have here, the percent that's pure alcohol would be 80% of those liters. Okay, so this is one way to organize it. You don't have to use the table. You can also just kind of write this into an equation, but by creating this table or getting used to making this table for the mixture problems, you're always going to have equation 1 in the first column and equation 2 in the third column. And so equation 1 is just saying liters of 30% solution, liters of 80% solution has to add up to 100 liters. And the other equation is saying, well, 30% of the first solution is alcohol, 80% of the second solution is alcohol. And the final, when we add them together, we want to have 50 liters that are pure alcohol, or 50% of what we had for our total. So then for this one, or any of these mixture problems, first thing I do is get rid of the decimal. So I multiply everything by 10 on this equation and get 3x plus 8y equals 500. And then you kind of have two options. I mean, you could do substitution. I think I chose to do, I did substitution on my paper, but I would argue that linear combination is fairly easy here because it's just 100. So like you could easily multiply this by -3, which would give me -3x, -3y, -300. And those numbers aren't that bad to work with, right? Actually pretty easy numbers to work with. That's going to cancel and give me 5y equals 200, and divide by 5, and y equals 40. And then if y equals 40, and I know that combined it has to add up to 100, I can plug that in. X plus 40 equals 100, or x equals 60. And then I want to, anytime I have a word problem, I want to respond in words. So that means I have 60 liters of the 30% solution and 40 liters of the 80% solution. Okay, that's what I would mix together. And those 100 liters would be 50% alcohol solution. Okay, it's a tricky problem, but this kind of chart setup helps you. And it's always kind of the same. So just like how these setups, like you're going to see these types of word problems and these types of word problems a lot, and the setups are really kind of the same over and over again, just different numbers. The mixture problems are kind of the same over and over again, just different numbers. So you have x plus y equals total, percent equals the percent of the total. That's the setup. Now, the candy problem is really like this up above. It's a little bit funky because they're selling it for $1 per pound. So I could make a table for something like this as well. It is like the mixture problem. This is pounds, so we're saying total pounds. And so we want to get 100 pounds of candy. We're going to sell it for $1 per pound. And then that's going to give us $100. And so what I'm doing here is I'm multiplying these two columns together. That's what I'm doing here as well. Okay. Now we have a $1.30 candy mixture. We don't know how many pounds we have of that. So we have 130 times X number of pounds. We have a 90-cent mixture. Again, we don't know how many pounds of that we have. And then we have 90 cents times however many pounds that is, 130 times however many pounds that is, and we want it to be $100 in the end, because we're going to have 100 pounds that's going to sell for $1. So this one's a little bit funny because they both end in 100 here, but that's really just because it's $1 per pound. So in terms of total pounds, I'm going to have some unknown amount of $1.30 candy, some unknown amount of pounds of 90-cent candy, and it's going to total 100 pounds when I mix it together. And when I mix that 100 pounds, I want it to be a $1 per pound mixture. So if it costs me $1.30, or if I make $1.30 per pound of X, and I make 90 per pound of the Y, I want it to total $100. So there's a difference here. This is really 100 pounds, and this is $100. You wouldn't put units in normally, but just to kind of differentiate for you why they're both equal to 100. It's just because it's only $1 per pound. Because $1.50 per pound, this would be 150. Okay. So then same idea, I get rid of my decimal first. So I multiplied by 10 and got 13x plus 9y equals 1,000. And then in my key, let's see, just so when you look at the work, in my key, I did substitution. So I said y equals 100 minus x. and then I plugged that in. So 13x plus 9y equals 1,000. And I plugged in 100 minus x here. And I'm not going to have space the way I wrote this, but yeah, we'll go back up to 20. So plugging that in, distributing through, we actually get, this is, the math ends up being pretty easy here. We get 4x equals 125. Was this when you thought I switched? I'll look at this one after too. So you get 25 pounds, and then for it to add up to 100 pounds, you must have 75 pounds of the 90-cent candy. Let me look. So yeah, this should be van. I think I wrote the wrong word here, right? Do you have vans and bus like this? Am I okay now? 4 vans, 3 buses, 7 vans, 14. Yeah, I just switched the words in the end. Yeah. Okay. Do we feel a little better, hopefully, about wording the problems? I can't really, it's hard. I don't have any classroom. I can't tell how lost you are. Hopefully that helped a little bit with those word problems. So 20 is getting a lot of questions. So let's do 20. There were a lot of asks here, and I don't know if we should really dedicate our time to doing a lot of these over and over again. But let's maybe choose a few. So 20 was asked several times. On a problem like 20, first thing let's do is get it in standard form. So I'm going to add 8x over and then subtract 23. So I'm just rewriting that equation. So it's x, y, and a number. I'm going to do the same thing here. So I'm just going to rewrite it. So it's x, y equal to a number. And then what could I multiply by? They all have coefficients, so I wouldn't be doing substitution. What could I multiply by to eliminate one of my variables? What do you think? Two. Yeah, I agree. I would multiply by 2 on this equation. And if I multiply through by 2, that's going to make that negative 8x minus 12y equals 20. Okay. And now if I add these two together, I'll just rewrite this one underneath so there's no confusion. This is where I made my error the other day. So my x's will cancel, and I'll be left with negative 3y. And what happened is I lost my negative on 20, or I don't know, I somehow wrote 3 and not negative 3 here. 20 and negative 23 gives me negative 3, y equals 1. So now I know y equals 1. I can go back to so I could go back to here, I could go back to here and solve for x. I'm going to grab this one. If I know y equals 1, then I know I have negative 6 equals 4x plus 10, or negative 16 equals 4x, just subtracting 10 over, and x equals negative 4. Now, what you should be doing, in particular on a test, I mean, when you're doing this many problems, as I didn't check them all. But on a test, what you should be doing is a real quick check to make sure that you feel confident about that answer. And so you don't have to even write it out. Like, you can just kind of do some quick mental math or even write some notes here. If y is 1, then that's going to give me 9 plus 23. And if x is negative 4, negative times a negative is going to make that positive 32. And then I just kind of do a quick check that that's going to be balanced. Okay, so, oh, that first one works. And then the second equation, same idea. If I plugged in 1, that would give me negative 6. And if I plugged in negative 4 here, it would give me negative 16 plus 10. So it doesn't have to be this really labor-intensive check, but just to go back up and make sure, like, yep, that's also going to balance. So when you move away from a problem, you should feel confident that it's right. And if you check it and it doesn't work, so like, what did I have originally? Well, I had written 1, or I had written negative 1 here, which gave me, I think, negative 1. So I had this incorrect on the key, and I had this, and I hadn't checked it. But I immediately knew it was wrong when someone said something, so I went back And I checked it. And when I looked at it, I'm like, well, -9 plus 23 is not going to equal, if I had -1 here, it would be this. This is what it would be. And I immediately saw that I had the wrong answer. So if you're on your test and you say, or me, and had this, if I had taken the time to check it, I would have restarted and I would have looked through my work and I probably would have easily seen, oh, I lost a negative here somewhere. And you can see that, like, because Y was wrong and that's what I plugged in, then my X was wrong. So it kind of snowballs, and you want to take the time to do that, to kind of check through things on a test to make sure that you didn't make a silly mistake like that. Okay. Let's look at 19 really quickly. So 19, just because it's the only one with fractions, and we talked about this kind of earlier in the unit, but if I have a fraction or a decimal, let's clear it first. So I just multiplied everything through by 2, which gives me -2 equals 5y plus x. And then looking at my other equation, I see, well, I can get opposites if I multiply by by 4. So that's going to give me, let me write it down here, -8 equals 20y plus 4x. And if I take my other equation and write it underneath, that's 17 equals, and I'm just going to flip these around, -20y and -4x. And this is a special case where all of these cancel out, and it's going to give me 0 equals 9. Because this is not true, this is a no solution. On the second quiz, which I haven't seen your group of quizzes, I've only seen the online ones. But on the ones I looked at, there were several people, there was one that was infinitely many solutions on that quiz, and several people put no solution. So if all of my variables cancel out and I'm left with something that's false, that's no solution. If all of my variables cancel out and I'm left with something like 0 equals 0, that's when it's infinitely many solutions. Okay. And a lot of people also wrote like that the answer was 0, 0 instead of writing a special case. So just kind of be on the lookout for that. And again, you're looking for everything's going to cancel out. Out of the ones that are left on this page, is there one you desperately want to talk about? Before I go, there was like 3 asked on the page before too, and we're going to run out of time. So both of them. All right, I guess I'll just keep talking at you. So on 21, we can't get away with multiplying just one equation. Now, you don't have to multiply by each other. So what I did is I chose to multiply this equation by 4 and this equation by 3, which is going to give me 24 and -24. Okay, so that was my choice. You could have done, like if you wanted to, you could have multiplied by 10 and 8, and you would have gotten 80s here, or 80, -80 somehow, make one of them negative. You could have done 8 and 6 and gotten opposites as well. I just chose to use smaller numbers so that the math would be a little easier. So that makes my first equation become 32x plus 24y equals, and then 24 times 4, 96. Multiplying by 3 gives me 30x minus 24y equals 90. Now my y's will cancel, and I have 62x equals 186. Dividing by 62, this goes in 3 times. Then when I go to substitute 3 in, so I'm going to take 3 and plug it into either of my equations. I'm going to choose the second one. 10x minus 8 equals 30. If I plug 3 in here, I'm going to get 30 minus 8y equals 30. And when I subtract 30, I get 0. So then dividing by -8 gives me 0. 3, 0 there. 24, it might be the setup that's a little tricky. So first I'm going to rewrite them. So 9x plus 21y equals -39. And then this guy would be 21x minus 12y equals -30. And then what I did to just have smaller numbers to work with is I divided, 3 goes into all of these. So I did like just divided it all by 3 or multiplied by a third and rewrote this equation as 3x plus 7y equals negative 13. And I did the same here. I just multiplied by a third, looked at a third of that, just so I had smaller numbers to work with. Okay, so you can always multiply by a fraction, or in other words, divide. And then because I had opposites already for signs, I multiplied the top equation by 4 and the bottom equation by 7. That's not the only choice that you have there. You could have worked with the x's as well. And so that, I'm going to move this way, is going to give me 12x plus 28y equals negative 52. And multiplying by 7 here gives me 49x minus 28y equals negative 70. So by multiplying by 4 and 7, they're my opposites. And I get 61x equals negative 122, which goes in evenly. That's negative 2. X equals negative 2. And then I plugged that in, and you can plug it into any equation here. And I got y equals negative 1. Okay. Let's backtrack a little bit to, let's look at the inequalities and graphs, and then we can go to the other remaining solving ones at the end. So somebody had asked about 12 for inequalities. So you will have graphing. That will be, so for this group, you're taking the online portion tomorrow. You won't have graphs tomorrow. All the graphs are on the paper version that you'll take on Thursday, just kind of so you know. But for my inequalities, I want to get my line, think about dashed solid lines, and then just be really careful with our shading. So first inequality here, subtracting x. We have a y-intercept at negative 7, slope of negative 1. Being really careful with details here. So dashed line because it's just less than. And then I can either test a point, or I can know that less than would be below the line, or testing 0, 0 would not work because 0 is not less than negative 7. And shade for that first inequality. My second inequality here, subtracting 5x, has a y-intercept at negative 3, slope of negative 5. So this one's a solid line. And it is less than, so, or if I tested 0, 0, it would not work. So I'd be shading away from 0, 0. And then I want to make it really clear where that overlap is. And that's 12. Now, something that doesn't happen on 12, but does happen on other ones, is just be really careful if you flip your sign when you divide by a negative. There's something to remember with inequalities. That one was asked about in the inequalities. On the graphs, first page on 5 and 6, so when it's not an inequality and it's a graph, we're looking for the intersection point. So we need an actual ordered pair x, y. Let's see, so on 5, maybe I add 10 over first on this equation, and then dividing everything by negative 10. Reducing that fraction, negative over a negative is a positive 2/5 x minus 1. So here's one line that I'm going to graph. My other line, 10y, if I subtract 40 over and then divide by 10, gives me negative 1/5 x minus 4. Here's the other line that I'm going to graph. And so when I graph these, so I'm at negative 1, 2/5, so 2/5. I'm going to get as many points as I can. I'm going to go backwards too. Just so that if my point is kind of on this half of the graph I have, which it is, I have some points over here and my line's really accurate. So there's my first line. Oops, didn't do a very good job making that accurate. Then my second line, y-intercept at -4, -1. Oh, did I go? No, this was positive. Okay, -1/5. I can go backwards, go up 1, -5, and then boom, there's where they meet. Okay, and then this is my intersection point. So I look and I go, okay, well, x is at -5 and y is at -3. Be really careful on that first quiz. There was sometimes that the graph was right, but then you wrote the wrong ordered pair, or you flipped x and y around. So just be really careful about that. 6 was asked about. So this has y-intercept at -8, slope of -2. I'm going to go backwards a little bit. Go even further. My other equation I have to solve. This has a y-intercept at 5, 1, 6. There's my intersection point. Oop, found my line, missed it. Make sure your lines have arrows, please. I do take points off. I take a point off if your lines are messy or don't have arrows. -6, 4 is where they intersect. Okay, those were the ones asked about. Do you want to do a calculator one real quick and we'll go back to solving? Look at one of these. Yesterday they asked about 2. So I'll give you a minute. I don't have my calculator in here, so I'm just going to go grab my calculator real quick.
Amazing, not counting that extra 1.5 FTE, whatever it is, cost everybody in the district $200. Or something along those lines. That's the top is 200.
Okay, so let's look at, you know what else is weird about some things? I can't see, like normally I have the boxes next to it to see people, but I can't see anyone. Kind of weird. All right, so to go into my calculator, these you'll definitely have on the online portion. What do I need to do with my equations first to use the calculator? And I know we're over on time. We're just gonna wrap up as much as we can. I don't want to cut review short. What do I need to do in order to use this to solve? Get them into y equals. So first equation in y equals, I'd have y equals -2x, and I'd have -7/12. It's fine that this is like an ugly negative because we're not going to graph it. We're going to use the calculator to kind of do that work. My other equation, when you write it in y equals, gives me 8/9 x minus 17/18. So now that I have my equations in my calculator, all of my graphing buttons, remember, are in the gray area of my calculator. You have the emulator of this calculator on your Chromebook. So I go into y equals, I clear out what's in there. If there's anything in there, you need to make sure that none of your plots are on. And then remember, we have to be careful that there's a difference between negative and subtraction. So the -2, we need to, there's a negative here to make numbers negative. This is subtract, okay? So when I type in this first equation, I'll show the buttons that I'm pressing. I'm going -2x, we're using our xt theta n button, subtract, and then for 7/12, I'm going 7 divided by 12. For 8/9 x, subtract 17/18. And to do the fractions, I'm just using the division. Then I go to my graph. If something's weird with our graph, we can adjust the window or how it's zoomed in with these two buttons. My graph's fine now. And then where do I go to find my intersection point? Second trace, yep. And then in my menu, I want option 5. And I have to enter, enter, enter. And there's my intersection point. Now on the quiz that I graded that had calculator stuff, a lot of you missed directions here. So round to the nearest 10th, that's to 1 decimal place. So I'm at 0.1, negative 0.8. There's my rounded answer. Okay. And you could go back, right, and watch the video if you needed to. If you're needing a refresher on calculator stuff, you can always go back to lessons from before. So you go to trace. So you go, so when I'm in here, I'm going second trace. So I don't want to just hit trace. I want to hit second trace and get to the calc. It should say calc on the top, calculate. Okay. Okay. Other questions that were asked on the review were these bottom solving ones. So if you want, I can just kind of talk through them. If you want to head out and you feel okay, that's fine. But I'll just kind of talk through the last 3 that were asked about. So on 15, you could absolutely do substitution and add 4y over. I chose to just multiply this by -3. Like I said before, I'm kind of favor linear combination, but so somebody asked about their quiz scores. I've graded anyone who took the quiz online, or for the most part, the remote students. If you're in the group that took it in person, I only have half of them. One set that is kind of like in transit. It wasn't there when I went to pick it up. It's being sent between the buildings, so I don't have them all yet. So if you don't see it in Power School, I may not have it yet. So I multiplied by 3, or -3, I should say. And I'm going to add that together with my top equation here. These will cancel, give me 6y equals -6. Divide by y equals -1. So I'm just going to take that and plug that in. Maybe I grab this equation, plug in -1 for y. Negative times a negative gives me +6. Gives me x equals 1. Okay, so that's how I went about solving this one. On 16, I multiplied the bottom equation by 4 so that my y's would become opposites. Now these would cancel. -7 and -12 would give me -19x. -7 and 64 gives me 57. And then that goes in evenly when I divide by -19. It goes in -3 times. Or 3 times gives me -3. When I plugged in -3, I get y equals 7, which is just plugging into any equation. On 18, I chose to multiply this bottom equation by 3. That way, when I write, what did I do? I wrote y twice. That way, when I combine it with the top equation, I'll just rewrite it. My x's will cancel, and I'll have -11y equals 11. Divide by -11, y equals -1. And when I plug that in, if I grabbed this equation, -x minus -1 equals -1. -x plus 1 equals -1. -x equals -2. X equals 2. Okay, and you have this key, so if there was one you didn't get right, I would restart it and see if you can get it correctly. Hopefully I don't have any other errors. Let me know if you do. Okay. I'll put the attendance link in one more time.